Hey students, welcome back. In the last section, you learned a lot of the fundamentals such as primitive variable types, flow control, Boolean logic and algebra, etc. Now you're going to be writing bigger and better programs, so you need to learn how to structure them as well as how to work with data. All of this fundamental knowledge helps build a stable foundation for you as you continue your software engineering journey. There's a ton of stuff to learn, tons of material to cover, but that's what makes this field both so difficult as well as so rewarding. It's why software engineers earn six figures and build the cutting-edge technologies of tomorrow. But one step at a time, this is a marathon, not a sprint. In this lesson, you're going to learn about functions. Functions are a way to reuse snippets of code, and they're fundamental to software engineering because number one, they help you organize code, and number two, they help you prevent duplicating the same lines of code over and over. Let's revisit our piz-paz function. I'm going to dump the contents of the file out to the terminal, remember with the cat function, short for concatenate. Hypothetically, looking at this code, what if I wanted to run it multiple times, but then each time specify a different range? Well, you could copy-paste this code and tweak a couple things each time. However, that's not a very efficient use of space, right? There's a better answer, and that's called functions. To get started, I'm going to create a new folder in module_0 called functions, and then I'm going to teach you a new command. cp, short for copy. cp takes two arguments. The first is the name of the file you want to copy, and then the second is going to be where you want to copy it to. Keep in mind that these arguments have to be direct paths to the source and destination, and so your arguments might look a little different than mine. I'm currently in my module0 folder. In order to get to m0c3.py, I have to go back up to my parent folder and then over to challenges before I can get there. This is called a relative path. It describes where a file is in relation to where you currently are in the file system. So, relative path to the file you want to copy, relative path to where you want to copy it to. For me, it's going to be functions, and then I'm actually going to change the name of it to functions.py. Now after you run the command, you can ls functions in order to confirm that the new file is in there, and then if you open it, you'll see it's the exact same file as m0c3.py. Make sense? cp, copy from source to destination. Now that we're in our new file, let's revisit the original question. What if I want to reuse this code multiple times with a different range each time? Well, let's start with the simple part. In order to explore different ranges, we need to not hard-code numbers inside the loop, right? So what I can do is I can create a variable called x right above the function here. I'm going to set it equal to the same thing, 101, and then I'm going to replace the 101 inside the loop with the x variable. Now the x variable determines how many times the loop runs. So I'll write my changes and execute the program. You can see that the output still prints what it did before, but then if I go back and change x to 16, then the output changes accordingly. Good. Now, let's talk about functions. A function is basically an alias for a snippet of code. It makes that snippet of code reusable without actually having to rewrite all of that code. The way you define functions in Python is with the def keyword followed by whatever you want to name your function and then parentheses at the end. That's important. And now with the function declaration, if we want Python to recognize all of that code below as belonging to that function, then we need to remember our scope, right? Go ahead and go into visual selection mode with V, highlight all those lines, and then type shift period or greater than sign. This indents everything to the right by one level. So I'm going to write my changes and execute my code. Oh, sorry, there's supposed to be a colon after the function definition. My bad. Now I'm going to write my changes and then execute my code, and it's still not working. Why? Well, I sort of hinted at it earlier, but remember, a function definition only defines the function name or the alias for all of this code. You actually have to call that function name or alias in order to run the code, right? So go ahead and flip back to your code, go to the bottom of the file, create a new line, and then we're going to call your function, right? For me, it's piz_paz, and then the most important part, parentheses. Universally across many programming languages, parentheses designate that you are calling a function. In fact, if you look very carefully, you can see that you are making use of Python's built-in functions range in print. Now, write your changes, execute your code, and you should see output. Okay, awesome. That solves the first challenge, which is reusing this snippet of code. But we haven't solved the other part. How can we get this thing to run with different ranges? The answer to that is input variables or parameters. You see, functions can take input variables or parameters whenever you call them. And so what we're going to do here is we're going to get rid of this x equals 16 inside the function, and instead we're going to put x inside the parentheses in the function declaration. What this basically does is whenever you call PysPas, Python expects you to give some kind of input in the parentheses. And now at the place where I actually call the function, I have the ability to specify an input. So if I plug in 15, write my changes, execute my code, you can see the output reflects that. And then if I go back and change that 15 to 43 and execute again, you can see the output now reflects that as well. Great. And now, the last part of this thing, I can run this function call multiple times with different inputs each time. After my PysPas 43, I can add in PysPas 2. And now you can take a look at the output and see it goes up to 42 and then it starts over again with 1. Fantastic. Well, actually the output's a little confusing. I'm going to add a print statement before the loop just to make it clear when the function's about to start again. And now if I execute again, you can see that it prints out this message every single time I recall the function. Alright, one last thing. What if I also want to change the message that's being printed out too? Well, I can just repeat the same procedure as many times as I need to. Inside the parentheses here, I'm going to add another input parameter and I'm going to call it message. Then in my print statement, I'm going to replace all that text with the message variable, and then down where I actually call the function, I can additionally specify more input, which is going to be the message. And then if you observe our output, the message changes accordingly. And that wraps up our lesson on functions. The reason we started with functions is because, again, they're fundamental to writing code and writing software, but more importantly, you're going to be focusing on writing good functions from now on in your programming challenges. You'll understand a little bit more when I explain the new challenge format in a couple of videos. For now, let's end the video here. In the next lesson, you're going to be learning about your first data structure, lists, or arrays. See you in the next lesson.